Okay, so today we're going to go over how to do a full segmentation of bone using ITK-SNAP. For today's demo, we're just going to do the lower mandible. All data sets are pretty much going to be from osirixviewer.com/datasets. You can see what they each contain based on the modality, and usually the definition of the file is going to be based on how big the file size actually is. So generally, the larger the file size, the higher resolution you'll get, or the more data sets that you'll get inside inside one of these CT, MR, or angiogram files that they have available. I don't remember which one we'll be using today, but I know that it's going to just have the lower jaw. So in ITK-SNAP, I already have it preloaded. If you don't, just go to File, Open Main Image, and import your DICOM series. In this case, the source material is going to be from patient CT. And from patient CT, it's going to be fairly simple to get bone out, and you'll see why in a second. Depending on the size of your data file and the speed of your computer, mostly your RAM, I think, it could take quite a while to actually load your set. Okay, so here is the main window in ITK-SNAP. Navigation is as follows. Left click allows you to focus in on one plane in the axial direction, and then the other two will change accordingly, as you can see. Mouse wheel to just scroll up and down in the one plane, like this. Clicking down on the middle mouse wheel allows you to click and drag. This is useful for when you've zoomed in on your image and you want to just move it around on your screen. And right click is to do that zoom in. So again, middle mouse click to pan around and drag your image. Mouse wheel up and down to scroll through one image slice. And then left click to simultaneously shift all other views that you're not currently on. Pretty cool. Okay, so like I said, we're going to do the mandible as the example segmentation for bone today. So first things first, find your region of interest. In this case, it's going to be somewhere here for us, right there. And today we're not going to do any sort of manual segmentation. We're going to do the entire process in their semi-automated tool. And the semi-automated tool that you can use in ITK-SNAP is located here. It's called the Active Contour Selection tool. So when we click that, you'll see your region of interest here in the dotted box. And it's going to be available in all planes, like this. Yours is not going to look like this. It might look like this, so that it surrounds your entire image. If that is the case, what you're going to do now is drag in all four sides until you have basically isolated your organ of interest, like so. And you're going to do that for all the different planes as well, just so that we know we're going to get exactly what we're asking for. So at this point, you'll notice that if I go through my CT, the organ of interest is actually larger than my bounding box, or this region of interest. So you have two options here. Option one is to resize your bounding box until it completely encapsulates your organ of interest, like this. Yeah, just like that. Or what I prefer to do, and you'll see why in a second, is actually just leave this bounding box fairly small and focused, at least at the start. So in this case, we're just going to focus on this part. Right there at the chin. Something small, just like that. Once you're happy with your region of interest like this, you are going to hit Segment in 3D. And it's going to bring up a new set of images. Basically, that region of interest is zoomed in on, or the region of interest box from the active contours selection has zoomed in on your region of interest. We're not interested in this view, we're interested in this window. And this window is basically, it's where we set our threshold values. Our threshold values are basically going to tell us exactly what we want to keep in terms of our segmentation, so our organ of interest, and what we don't want, so the boundary. The boundary in this case is whatever is going to be in blue, and whatever we keep of our region of interest is going to be in white. The way that you set your boundary or your region of interest is over here on this panel. So here we see the lower threshold and the upper threshold sliders. These values represent the Hounsfield units, so the brightness or the contrast in your CT, MR, or whatever imaging modality. And when we change these values, you can see how your region of interest is actually isolated, and we can flip it. So here we were only going to get the bone because we know that this is mandible. However, if we flip it, let's see, like this, we can get everything else that's not bone. So in this case, I think this is dermis, layer of fat here, and then some voids, just like that. And then by continuing to play with it, we can get even more specific. So now we would only be getting the upper layer of skin, for instance. But for today, we're just going to get the bone, and bone is very bright on CT. So we just turn our upper threshold all the way up, and our lower threshold, keep going up until you get a pretty good outline of whatever region you're currently working with. So that looks good. Once you're happy with your segmentation, hit next. And the second step in this entire segmentation process is called the bubble growth. So ITK-SNAP does a semi-automated segmentation module by placing down these bubbles. So once you click Add Bubble at Cursor, it will literally add a bubble at your cursor. And what these bubbles are going to do in the following step is that they're going to grow into your region of interest, and then they will stop growing once they hit the blue area. Essentially, this is going to give you a somewhat perfect or near perfect representation of your particular region. The reason why you won't want to make your region of interest so big is that sometimes you're going to get two regions that are very similar in contrast. So for instance, teeth of the upper maxilla versus teeth of the lower mandible. And if we're only interested in either the maxilla or the mandible, if we have regions that are very close to each other in contrast, like those teeth, these bubbles will just fill both upper and lower parts of those teeth in, creating one solid model. In that case, it's not great because we suddenly have parts of our organs that we don't want. So it's for that reason that I do the stepwise region of interest segmentation, like very small region of interest, step by step, instead of trying to get the whole thing at once. If that wasn't clear, I can show you an example of that later or in another video. I'm not sure yet. But for now, the idea here is to put down these bubbles in different places. One of the most common questions is how big should these bubbles be and how many should you place? When you're working with bone, you don't really need too many because the outlines here and the definition of the regions are just so good. I usually just do it in one plane in the axial direction, and then I just make the bubbles fit into the region as best as I can. This is honestly good enough to be able to get an accurate segmentation of this particular organ of interest. We're just going to add one more here, and then that's pretty good. Okay, so now when we're happy with how many bubbles we have, you can add more if you want. You can probably get away with one in this case, but that's okay. We're going to hit next on this screen, and then we're going to tell it to grow. So you just hit play, and over time, as you can see, the red grows into the white spaces, but never leaves the boundary of the blue. And you can begin to check whether or not you've gotten your entire model by just scrolling through with your mouse wheel in all the planes. And once you're happy with how the segmentation has gone, hit pause. Your step size is basically going to determine your iteration. Your iteration is how many growth iterations. That's a bad definition. The iterations basically say how many moves of growth your bubbles have taken to fill up your object. Your step size just, I'm pretty sure anyway that it increases the speed at which it does this, but it's sort of taxing on my system with a limited amount of RAM. I think I'm pushing 6 gigs or something. but you can play with this and see if you get your segmentation out faster. I just leave it at 1. 1 is fine. If the segmentation takes a long time, then I literally just walk away and get coffee or something. So now that we've got our organ, we hit finish. And as you can see, it's colored, but we're still missing quite a lot. But we can see our work so far by hitting update in the bottom left-hand corner here. And my screen keeps resizing itself every time I switch modules. And there we go. That is the chin of our mandible, plus the tooth. So the tooth, we probably didn't want that, but yeah, we can clean it up either with the manual tools, which I'm not going to even go over today, or you can do it in some other post-processing software. Okay, so let's fill out the rest of the mandible. And again, we're going to do this stepwise. So back to your segmentation active contour menu. You're going to move your region of interest out this way. We're going to go this way first. Okay. And if, as you can see here, the window disappears, like your region of interest for the active contour is gone here. There's no dotted lines or anything. The reason for that is because we are no longer, our crosshair or our focus is no longer within it for these two planes. So to get that focus back, we go here, the crosshair mode, or 1 on your keyboard. We click to where we want to go. It automatically zeroes in on it on the other planes as well. We go back into our active contour, and as you can see, there's the boxes. So let's make this a little bit more encapsulating this time, like so. And we're just going to get the entire, this is left side, right side, right side. Okay, we're going to hit segment in 3D now that we're happy with our region of interest, and we're going to go through that entire process again. So bottom window to select or to determine your boundaries. The nice part in ITK-SNAP is that your upper and lower thresholds between segmentations are going to be saved. So we don't have to touch this anymore, that we know that we're pretty happy with where we're going. We hit next, we add our bubble, we size accordingly. In this case, we're just going to do 1, and you'll see how powerful 1 is, and then we're just going to tell it to grow. And we sit back and watch. So this slice is already done. I'm pretty sure all the axials are done. It's just creeping up in the other 2 directions now. And that's the border. Perfect. Good. We hit finish. Hit update. There it is. We've almost got all of the ramus in our model as well. So let's finish the right side. We're going to go through that process again. So go to your region of interest, click on it so that we're zeroed in all our axes. Segmentation, window of region of interest window, scale to fit, scale to fit, scale to fit, and this will be a good time to actually demonstrate what I was talking about earlier about doing small regions of interest instead of one huge region of interest. So as you can see right now in this pane, if we were to take the whole thing, our ramus, or the absolute tip of our ramus up here, looks connected to the rest of the rest of the skull. We don't really want that because that's somewhat inaccurate. I'll show you what happens though if we were to do this. So I'll just do this quickly. Next, add bubble, go. So this is with a total total segmentation. There it is. This is what we do not want. This is no longer part of the mandible. But because it was the same contrast, or I'm sorry, the same Hounsfield units, the program picked it up as going to be part of your model, and we don't want that. So if we update this, yeah, this part up here is not part of your model. This isn't a big deal in this case because you can always edit this out in 3D editing software, or in the segmentation you could have hit pause before you hit this region. But this problem just kind of exacerbates itself with more difficult organs like anything that involves soft tissue, for example, or very close bone structures that you don't want to have joined, especially in the knee. The knee gets tricky with this as well. So for the purposes of like good form, I'm just going to tell you not to do a big swath of segmentation unless you're in the total clear and your organ of interest is completely isolated. So I'll show you what I would do instead. So we don't need this anymore. So I deleted this entire thing by just hitting Control Z or undo. So Control Z or Control Z on your keyboard undoes the last move. So now it's gone. It doesn't automatically update here. You actually have to hit update, and it's gone. So let's do the segmentation actually correctly. So again, target of region of interest. There we go, bounding box. And instead of going all the way up, we're going to stop here. Right there, where there's a clear line of delineation. We're going to check all our axes. Pretty good. Okay, segment. Boundaries. Good. Next. Add the bubble. Next. Let it grow. Stop once it's completely done. Finish. Update. Good. Good, good, good. We're still missing part of the bone here. So now we're gonna aim at the part of the bone that we're missing, and from here you've got several options, one of which is to do it manually in every single slice. That's going to take forever. Instead, we're going to get our region of interest box, and we're just going to zero in as closely as possible to what we're missing, like this. So as you can see, the box this time is far different from, the box's geometry is far different from what we had before. It allows us to be more specific and detail-oriented about the region that we actually want. That should be okay. Segment in 3D. Oof. Anytime that you get these grays, sometimes segmentation doesn't pick it up immediately, or if at all. In this case, we can just lower the threshold and make it a little bit brighter, just a little bit brighter. Add your bubble, hit play, and we're off. Another benefit of having these very small regions of interest is that it's very not taxing on your system. It completes the calculations very quickly. We hit finish, we hit update. Much better, much cleaner. So it's still a little bit flat up here, which isn't realistic, but that's alright. We can do another round of segmentation if you really want. So once again, let's go ahead and do that then, and finish this off properly. Zero in on what you're interested in. Just like that. Segment in 3D once again. We're going to go through that process. We're just going to have this bubble grow. Oh, okay, this is another problem. If your region of interest becomes too small and too pixelated, your bubbles won't actually grow. So we might be at the maximum fidelity that we can possibly get out of this. Let's try one more. Let's see. Oh, that's better. Okay, so we'll pause it right before it gets to this area, because we don't really want this. We want a nice rounded vaulting shape. Finish. And now when we zoom in, it's no longer flat. Nice. That looks much better. Okay, that's half of your mandible done. More than half, I guess, because we're past the chin. We're going to go do the exact same process for the other side. I'm just going to do this somewhat quickly because we already saw the basics of it from before, but here we go. So now I've lost my region of interest because it's literally somewhere on the right hand side. We're just going to hit reset. Anytime that you lose your bounding box here, or your region of interest, just hit reset, and it will reset itself. Draw it in. This time I know that we're pretty good. in terms of our segmentation up to a point, and that point is somewhere here. Unlike the other side, this is a very good definition here. I'm not sure about all the other sides though. Yeah, there. So it still looks like it's connected. So we're going to have to do that part out separately, but the rest of it should be fine. Segment in 3D. I changed my lower threshold earlier. That's close enough. Add that bubble, so we'll do it with 3 this time. You could really get away with 1. Next, hit play. Almost there. That looks good. And something was connected up here that I wasn't too happy about or wasn't watching. I think that's still part of the mandible, so that's not a problem. If this does happen to you, where you're suddenly like, oh no, I've gotten another organ that I didn't want, you can finish your segmentation from this menu and edit it out later, or you can just hit rewind. Rewind basically just gets you back up to iteration 0, and you can do your segmentation all over again. In this case, it wasn't so bad because I'm pretty sure that this is actually part of the mandible. So I'm just going to let it run again and see what happens. I'll stop it there. Yeah, it was part of the mandible. Cool. Okay, let's update. Almost there. As you can see, I missed an entire region here. We'll go back and fix that in a second. And by in a second, I mean right now. Okay, segment this. Next. You'll notice that I normally just work in one plane. You can work in multiple planes, you can work in either or of these planes, whatever you're most comfortable with, or whatever your organ actually demands of you. Still a couple lines there that I'm not too happy with, so let's fill those out before we do anything else. Be good. There we go. One bubble should do it. There we go. Finish. There we go. Those are now filled in. This looks pretty good so far. I'm pretty happy with it. Okay. I lost my region of interest, so we're going to reset it. We're going to zoom in. That looks good in this. We have here. Looks good. And this also looks good. This one needs to be cleaned up later. Focus. Uh-oh. Update. Good. Oh, we're missing that part here, so we'll go and fix that in a second. Okay, now let's get the tip here. Reset ROI again. Okay, we're going to do the segmentation up to that point so that we don't get this part of the skull. Segment. Change my threshold values a little bit so it's easier. Set my bubble. Let it grow. It's pretty good. Update. Okay, we're getting there, we're getting there. Okay. Lost my region, found my region. Okay, let's go through this again. Being careful not to get too much into here, which I just stopped. Yep, okay, I'm okay with that. Okay. I wish I could get this cleanly, but I think it's going to be manual. Let's try it. I'm not going to do manual today. Segment in 3D. I think we'll be okay. Okay. Finish. It's going to be a little area that's been squared off. Yeah, you can see it there. I would go in and manually clean that up if I were you. Or you can just smooth it out in post-processing at a later date. What are we missing? We are missing something on the right-hand side. Ah, there it is. Reset. Bone is incredibly easy to segment out. It's actually quite nice to do. It's very straightforward and simple, and you don't have to mess around with your thresholds between segmentation attempts. It's just so bright. Finish. Let's see what this looks like. Much better. We're missing that weird strip for some strange reason. Zoom in on it. Do it again. There you go. Updates. There is your mandible. It is complete. Tooth and all. Okay. So from here, I look at it, I think to myself, that's pretty good. I'm happy with it as it currently stands. We're going to export it as an STL and get it ready for 3D printing. Because why else would we have this? You're going to go to Segmentation, up here in their toolbar, export as surface mesh. It's going to ask you which labels will be exported. Labels are over here. It basically defines what colors you have on screen. Each label corresponds to a particular region of interest. For today, I'm not going to go over how to use these things effectively, since we only had one label anyway. So we're just going to export label 1, red, as a mesh. I work in STL format. And change this, change the path that it goes to, because by default ITK-SNAP dumps your surface mesh and anything else you save out of this into the folder of your source data set. And those folders are a mess. It's like 8 folders deep sometimes, and it's impossible to find it. I'm just gonna toss it on my desktop. Mandible. Save. Finish. It's gonna save out your STL. Okay. We're gonna do some editing inside Meshmixer now. So launch Meshmixer. Okay. So we're gonna prep this for 3D print with one caveat. So to get your STL into Meshmixer, you hit import, find your file, or you can drag and drop it into the screen, doesn't matter, but for our purposes here. This loading bar shows you that it's a fairly large file, like it's fairly detailed. Depending on your system and the strength of your computer, this might really slow down your system. We're currently looking at 200,000 or just shy of 200,000 triangles of our model. That is absolute overkill in this case. It doesn't so much matter for 3D printing. it just makes editing your models an absolute pain, and your file sizes way larger than they need to be. It's great that it's nice and detailed like this. You can see all of the stepped effect here coming from CT. So this tells me that that CT wasn't exactly super high res. So what we're actually going to do, go to your selection screen, we're going to reduce our triangle count. Reducing the triangle count decreases the surface quality of your model somewhat. Well, it depends. If you reduce it by a ton, it's going to look like not great. But if you reduce it by just a little bit, then you should be okay. You'll have a very small loss in quality relative to your space savings. So we're going to just hit select, click anywhere on your model, and hit E. E for selecting everything, like this. It's going to glow orange. We're going to, inside this menu, you're going to go to Edit. You are going to go to Reduce. This will take a second depending on the size of your model and the speed of your computer. Okay, here we're going to reduce the triangles by a percentage. You can do it by a triangle budget, which basically just gives you a fixed amount of triangles. I just usually go with percentage. This is where you can enter your percentage. You can type it in. In fact, you should probably type it in. The reason is because for every single percent that you move the slider, this thing has to recalculate. So you might as well just do it all at once. Reduce type, leave it to shape preserving. And today, just shy of 200,000. A 50% reduction will get us to about 90,000, and you'll see the difference in quality. So if we just hit accept, in fact, it's already done it. There you go. We have a very, very small reduction in quality relative to how much space that we'll actually end up saving later. And look, my system's far less sluggish than it was before. Okay, next step to 3D print is to just literally run the inspector to make sure that we don't have any non-manifold faces. Your object is actually 3D, and it has depth and width and all of those dimensions. And you don't have any pieces that are just floating around in midair. And a couple other things too, but those are usually the main ones. Hit inspector. As you can see, there are a couple of errors. Might just be backward face triangles. Auto repair. All done. All done. And then we export this file into the Mandible. Mandible edited. We'll hit save. Good. So we're ready to 3D print that file completely. You know, you got to slice it, but I mean, your 3D model's ready to be printed. One of the questions that I typically get from people that are working with mandibles, orthopedic surgeons, maxillofacial surgeons, etc., plastic surgeons, is how do you mirror one side versus the other? So let's pretend that this tooth is a tumor. The general procedure here is that they'll take, when the tumor gets removed, they need to be able to base like a template right onto the patient's bone, like a graft template or steel mesh, for example, to strengthen that region where the surgery was done. And in order to do that, they need an intact jaw. Typically, the process for that is they take a cast or a scan of the patient's jaw, and then they'll have a company 3D print the jaw that's been mirrored so that they don't have the tumor, but they have the same contour as the other side that's unaffected. That way that they can actually bend their plates properly. So the question is, how do we do that in this program? The answer is somewhat simple. All you need to do is, let's say that this is the tumor side, so we don't want this because there are defects, and we want to bend our plate so that it fits our patient. We're going to go to edit this. We're going to plane cut in the edit menu, and this is going to allow us to, well, as its name implies, cut our object on a plane. These rounded semicircles here allow us to tilt this plane in a variety of directions, with green corresponding to the y-axis, the red corresponding to the x-axis, and the blue, if I can find the blue corresponding to the z-axis. Of course, if we just rotate it around the z, it doesn't matter. And for our cases, we want it like this, in a perfect 90-degree angle, even though our jaw is slightly misaligned, but that's okay for today. So that means we have to rotate it here, grab a hold of this, go all the way out to the outer ring. This will allow you to snap in 5-degree increments and make this process a lot faster and easier for you. We're going to slice it right down the midline axis at 90 degrees. And we're going to click on this fat blue arrow to tell us to keep this side and get rid of this side. We're going to hit accept, and it's gone. So that's part 1. Part 2 is to then mirror this part. And thankfully, there is actually a mirror option inside of Meshmixer. It's right here, inside the edit menu, right at the top, mirror, click it, and there's our mirrored object. So now we have a completely symmetrical jaw that the surgeon or doctor can then use as a template to bend their graft and or supports. We hit accept. Ta-da! We're going to run the inspector again to make sure that we're ready to 3D print this, and we are. We're going to hit done. We're going to export this as a separate file. So this is going to be Mandible, edited, mirrored. Save. So now we have 2 edited STLs, one with a tooth that's the actual jaw that you get from the patient, and one without the tooth but with the right hand side mirrored, as an example of mirroring anyway. Good. Okay, let's finish this off for 3D print. Okay, so let's get this model ready for 3D print. So we've already exported this as a separate STL, the Mandible edited mirrored file. We're going to be printing this, or example printing this on an FDM or Fused Deposition Modeling class 3D printer. This encompasses your TAS Lulzbots, your Ultimakers, your Prusas, your Deltas, and your Makerbots. For today, we're going to be showing off how to do it on a Makerbot because I know how popular those are. So Makerbot, open up Makerbot desktop, and we're going to prepare this thing to be printed. So here is Makerbot desktop. It's up. First step is to make sure that you have the correct type of device selected. In our case, I'm just going to show off how to do it on a Replicator 2. We're going to set our settings. So inside of here, we're going to set the settings as if we were going to print this with PLA. Standard quality as a preset is fine. I don't know why my extruder temperature is so high. I think I used to run it at 230 but kept running into problems. So for the Makerbots, I actually do PLA at 205. The rest should be left as default. Extrusion speeds are completely fine as default. Infill, your infill density is just going to describe how filled the interior of your object is. Nobody will actually see the inside of your object, and that's why you can play with your infill density. The lower your density, your weaker and lighter your object will be. The higher your infill density is, the more dense your object is, the more material you're going to have inside your object, the stronger your object is in general. But it's going to increase the amount of material that you use, obviously, and it's going to increase the amount of print time as well. So you have to balance the two. Your infill layer height, it just describes how thick you want your infill layers to be. Infill pattern, I just leave it hexagonal. If you wanted, you could do like a cat fill, and they look like cats, but you can't really see it. Under model properties, your layer height is going to determine the resolution of your model. Default, I think for standard, is 0.2 millimeters. I find 0.2 millimeters to be pretty good for what we need, and it's going to be excellent for this model because the CT resolution is going to be the limiting factor anyway. Number of shells is how many envelopes are going to surround your object. This is going to be the external perimeters that the world actually sees. The higher number of shells, the stronger your model tends to be. Again, it's going to increase your print time, it's going to increase how much material is going to be needed. And I find that generally the increased number of shells actually makes your model look better, although that might just be me. Less gaps anyway. And if you're going to be making a mold or something that's meant to hold some sort of a liquid or anything that's has low viscosity, increasing the number of shells tends to make it a little bit more watertight, although it's still not a silver bullet. Those are your most important parameters for this, and except for this particular model, I'll show you one more parameter that's going to be important. Okay, so let's add our mandible. Mandible, edited, mirrored. There it is on the stage. I like to have my model facing me. Sorry about that, there was an announcement over the PA. Where were we? Okay, I've rotated my model so that it's facing me, mostly for vanity reasons. Okay, that's ready. When using this piece of software, you want to make sure that your object is laid flat completely on the bed. Sometimes it has a propensity to like have floating midair or something. It's kind of strange. Lay flat, just mash on that button. It's already touching, it's okay. Check your dimensions. This looks about right. It looks right in the size of the print bed. Okay, so now we take a look at our model's geometry, and as you can see, a lot of it looks like it's just in midair. A lot of it. You can get away with angles that are less steep, so usually at about 45 degrees the cutoff becomes too steep, 45 degrees or anything higher. In cases like this, we call our models possessing severe overhang, and the printers are not going to like that because it's just going to be printing in midair, and your objects won't come out either nice looking or at all. Like, it'll just look like a mess. So to combat that, we're going to go back into settings. We're going to go back into supports and bridging, and we're going to make sure supports are turned on. Supports are going to act as our scaffolding, just like as in a building, as it comes up off the ground and is built. It's going to add a firm and secure base for these overhanging regions so that they come out properly. Okay, we're going to hit preview, and obviously this is going to let us preview our model. Depending on the size of your model and the complexity of it, this can take quite a while. This one is progressing pretty okay. And if you hear that that sound that's going on in the background right now, that's the Form 2 working away. I didn't realize how loud it actually was on my microphone until I listened to the previous segment. So sorry about that. But as a shameless plug, the Form 2 is awesome. And if you hear the other whining noises, those are our TASs running in the background. I also didn't think that my microphone would pick them up, so I'm sorry about that. It'll get there. This is another one of those get up, leave your computer, and get a cup of coffee moments. Or walk around or whatever. One of the most common questions that we get around here is what kind of 3D printers do you guys use? In our lab, we have access to some of the higher end stuff like the Connects and the Objet 30 Pros. And I guess the Dimensions, which are still kind of high end, even though they're super old now. At least the ones that we have access to, but they're okay. We try and stay away from those for a variety of reasons, including cost and reliability. No doubt the models that they produce they're pretty good. The ability to control the meso level structures and actually control how strong your parts can be is limited at best. Plus, again, the cost is just insane for each print and the actual service contracts involved in those and such. So typically 99.999% of our 3D printing is done with either a TAS Allspot 5, and we're eagerly awaiting the 6s to be sold here in Canada. We currently run 3 of those in 3 different configurations. One has a dual nozzle setup, one has a flexible nozzle doing Ninja Flex almost 24/7. Ninja Flex is so good. And the last one is just a vanilla 0.35 millimeter solid extrusion nozzle. All of them are the newest hot ends, so they can reach up to 290 degrees Celsius without triggering a kill command, or I guess hitting the maximal thermal temperature for the TASs. And that's useful for things like high strength nylons and polycarbonate. The other printer that we use to round out our 99.9% use case scenarios is the Form 2 that I mentioned a while ago. It's our SLA baby. And the prints that it produces are really, really nice, and especially in clear. Oh man, there's a lot of post-processing work involved to get it nice and super clear, but it's definitely worth it. And I'll do a tutorial on that one day, although it's pretty self-explanatory. Anyway, I'm going to stop talking about the other printers. Here is what our model looks like. So you can scroll through these layers inside Makerbot Desktop to see what each step looks like. There's the infill, the typical honeycomb shape that we'd be expecting. If you selected cat fill, these would look like cats, and if you selected shark fill, they would look like sharks. These are our support structures that you can clip off after your model is finished printing, and there should be minimal scarring on your model, depending on the density of your scaffolding anyway. So usually I do this just to check that there's nothing weird going on with my model. There are no errors, there's no weird backward faces that didn't turn out and escape Autodesk's or Meshmixer's pre-check. So we look good. So now we just hit export, and then you can take your file, load it onto an SD card, and put it into your Makerbot. Or you can connect your laptop or PC or whatever, Mac, any sort of computer really that runs Makerbot Desktop, directly to your Replicator 2 or your Gen 5 or your Z18, whatever flavor of Makerbot you have, and run it directly from your PC. And that's where we're going to end the tutorial today. But we just went through all the steps from patient DICOM CT all the way to editing for prep to 3D print, or editing to prep for a very basic surgical prep guide. And now we just exported our file for 3D printing. So expect more videos in the future. Thank you for watching.